Good evening, class. My name is Gabriela. I used to be a former student here about 2 years ago, and your teacher has asked me to come and speak to you about mass and motion down an incline. Alright, so our lab um, was based on a group of friends that went to a roller, as you see the picture, I can't say the words, to a roller coaster, and they were like, during the day was so busy, so there were so many people that were there. So in the evening, they wanted to go for more ride, but there weren't that many people. So they were like, "Oh, will it go faster? Cause or slower because there's like less students there or less people in the roller coaster." So this lab was in order to answer that question, what we came up with. And our group's prediction was that the more mass there is, the faster the roller coaster will go because of gravity. So before we get started, I'm just gonna go ahead and quickly tell you this measurement. If you want, you can write it down. It's gonna be velocity as you've just learned it, meters per second. Acceleration will be meters per second, and mass will be measured in grams. And the position, which is also known as distance, will be in meters. And the one equation that you need to know is acceleration equals to force times over mass or divided by mass. So let's look at a history before who did this research. And some background is Galileo. He was interested in the mathematics of motion. So when he was under house arrest during his lifetime, he started doing research and trying to figure out how actually speed and an incline and everything works. So what he did was he didn't have all the measurements that we have now. So what he did was he would throw down, as you can see in the picture, he would throw down um, ball down an incline, but it went so fast that he didn't know how to measure it. So he he figured out a way to slow it down. As you can see, the little things that are there, the metal things, it's a way of making sure that the ball was slower. So his results, I will discuss it at the end, along with our results that we found. So for our materials, what we used was a motion detector. We used a cart with tracks, different weights, computer logger with logger pro program. And the procedure was, what we did was, as you can see in the picture, first we weighed the mass of the cart, which was 181 grams, and we let it go down the incline, as you can see in the diagram. And we did that 3 times, and then we added weight like 50 grams on each side of the cart, and we did that 3 times again. We let it go, and someone stopped it at the end. And the third time we added another 50 grams on each side, making a total of 200 altogether so far that we've added. And we did the trial 3 times, and according to our table that the data was collected, you can see that the mass of the carts is shown here, and then the trial 1, 2, and 3 was in meters per second, which was the acceleration, and here's the average and uncertainty. So let's look at the uncertainties first. The uncertainty for the mass was calculated by the difference between weighing according to the weight that we had, which was 0.5 grams. And then for the acceleration, how we calculated the uncertainty is we took the largest number from the trial and subtracted it from the lowest number from the trial of the three, that is, and we divided it by 2. So whatever we found, that average was our uncertainty, just to account for any errors or mistakes that occurred. And for all the 3 trials, as you can see, the average we had to average it out so that it's like we have the average, not just one trial or 2 or 3. So based on this, we were able to graph it. And in the graph, as you can see, the acceleration, which is in mass per second square, was graphed in the y-axis, and then the mass in grams of the cart was graphed in the x-axis, and the slope of it was found to be 0.0022, and its uncertainty was plus or minus 0.33 sorry, excuse me, 0.00036, which was measured in meters per second square per gram. And what the slope tells us is that the uncertainty was greater than the slope actually. which means that the slope is negligible. Meaning by that is that it can be within the range. The uncertainty is plus or minus, which is bigger. The number is bigger than the slope. So the slope could either be zero, or it could be negative, or it could be positive. So that means that we can't say it's increasing or decreasing because the uncertainty. So that's negligible. So based on the graph, we can't be able to say that it increased or it didn't. So uh, if we look at the graph, we can see that, let's take a trial 2, for example. We can see that as mass was added, it kind of increased a little bit without adding the uncertainty, however. But once we added the uncertainty or subtracted it, they were around the same range. So our conclusion was that mass doesn't have any effect in how um, the speed, sorry, excuse me, mass doesn't have any effect on the speed of an object, because the mass will end up canceling out. Or so when we find acceleration, it's like force over mass. So the force over mass of the weight will be proportional with the other one. So if there's less, that means there's going to be less, and then if there's more, that means there's going to be more. So it's going to even out. So our conclusion was that it doesn't have any effect, and it's going to go as fast as it did during the day. And that's all for today. Thank you for listening. Anybody have any questions? All right, thank you, and these are my sources. Thank you for listening.